Before I start, I realized that I made a mistake with one of the figures in one of the earlier classes. This was lecture 3, and one of the students pointed this out to me, and I couldn't quite answer him right. But when I thought about it, I figured I'd made an error. So the error was, if you look at the derivation of the position using the rotation and translation formula, this one in particular, this is lecture 3, then these axes were actually wrong. The axis x1, y1, and x2, y2 were wrong. So I'm going to correct it right away. So if you want to do this correction, you can do it right now, or I'll just post this as a corrected file. So correction to the axis. So I'm erasing this axis. Well, I didn't have to do that. Hold on. Let me undo that. I'll erase this axis. I don't need them. And I'll erase this name. Okay, so the correction is I need to draw it like this: x1, y1, and this is x2, y2. And why this is needed is because if you look at this formula for q1, the position of link q in frame 1, okay, is going to be r21, which is this angle, times the position of q2 in frame 2. So this is where the origin of frame 2 is. So this link, the point Q, is a distance of L2, and that's what is over here. So it's the distance from the origin of frame 2. So let me write that down. Distance of Q from origin of x2, y2, or distance from P, okay, from this point. And same for point P. It will be the distance from frame 1. This should be somewhere in the, I think it's in the previous, yeah, it's right here. So this needs to be fixed too. So correction to axis. This is y1, x1, x2, y2. And I said why this is true is because if you look at position of P in frame 1, this is frame 1, that's basically at distance of L1 from O, or the start or the origin of x1, y1. So that's why you have this. So distance of P in, sorry, from origin OO. Okay. Okay, so I'll be using this figure again when we derive the double pendulum. Any questions on this?